and we also have one in Europe. So we're pleased to be here. Thanks to Joe and Amy and the rest of the team for inviting us out. This is the first opportunity we really had to kind of do an event together, and so we're really excited to be working with IP Pathways. Okay, so let's see. Oh, I do have a clicker, so I guess I should use that. All right, so what I'm going to talk about, by the way, ransomware is okay. I'm the third or fourth speaker, maybe the fifth speaker to talk about this a little bit. I'm going to give you kind of a different perspective on it because what our company does, we're on the front lines of actually detecting this stuff. We're watching it happen. We're seeing some of these disasters unfold. Sometimes, this is often a situation where like we're being called in after the fact, but we've seen a lot of this stuff actually occur, and so we want to share some of our experiences kind of from the trenches about kind of what's been going on. But let me back up a little bit and talk about what I think is the biggest challenge today in cybersecurity. And the biggest challenge that we see is that threats are primarily moving from static to dynamic. And that is really one of the big issues. Much of, I was just reading an update today on the new Black Matter ransomware that has just recently come out. And there's a number of hashes and IOCs and things like that to go and program into your snort box or rules to put into your SIM. But that's kind of like part of the problem is that this stuff occurs, and then we wait to get some sort of briefing from CISA or something else, and then we hurriedly go and put the indicators and the signatures and the policies together to go try to detect it. But if you're like the subject of this, it's too late. If this is actually rapidly propagating and you're the target of this, you don't want to be the first person to kind of say, oh, by the way, we're the case that everybody's learning from. And often these things are proliferating so quickly, it's not readily available, that information. And so this stuff might be around in the wild going on for weeks or longer before a lot of the indicators get out there. But this is primarily the problem that we have, I think, in the industry, which is we're still very reliant on recognition technologies to tell us if we see something that's bad. And so that leaves open a whole nother set of like problems when it comes to, well, what about the unknown stuff? Zero-day threats, we've been talking about that for a lot of years, over a decade. Mostly that was exploitation of unpatched software flaws in operating systems. But now we see it in VMware, we see it in devices and firmware. We're seeing it across the map. So it's not simply just related to software vulnerabilities. What we're finding is that these attacks constantly change. We're throwing billions of dollars in cybersecurity right now. Billions. We're spending billions on it. Okay? And yet we're not stopping ransomware. It's like proliferating. So what are we doing wrong? What are we not figuring out? What are we not catching? And vendors are all, of course, talking about it, and ourselves included. And we're talking about the problem, but the solution is very, very hard to come by. So our focus is the detection side. Detection and containment. That's what our company is focused on. And what we think the problem is and where the focus needs to be is on dynamic threat detection. And that ultimately is, I think, where we're going to find the answers. Meaning, we aren't going to know, or let's not depend on the fact that we have to know the signatures, the rules, the IOCs in advance, because we're just not going to know that in order to detect dynamic threats. Okay? So they change constantly, and we're going to see this greater shift towards dynamic threats. So we've got to have the ability to do dynamic threat detection. This is what I refer to as the managed security generational model, and it tells you a little bit more about the history of where we started in the industry, particularly around SIM products, security event information management. And SIM is sort of this category of these solutions. Primarily, it's the platform that people have used traditionally for a lot of years for threat detection. And in the early days, we were primarily doing like aggregation of logs. And a lot of that was as a prelude to compliance. So if you were a bank, financial institution, you need to do FFIEC or any of that, they were one of the early requirements of people to, or of organizations that required to do compliance. But most of where the industry has really been in correlation and in static threat detection. And that's really where the typical like MDR, XDR, SIM solutions, that's where they live. But remember, this is like 20, 25-year-old technology. So when we talk about Generation 5, Generation 6, which is really where we are positioning our company, there is a fundamental reason why that we are focusing on what we call analytics as kind of this foundational platform. We believe that cybersecurity has become a data problem, a big data problem. Okay, and the reason why is because there's so much data being produced, the attackers are essentially hiding in plain sight. They're buried in the data. And so our approach is to analyze the data continuously using a big data ingestion capability built into our product or our solution, and to constantly analyze all of the data continuously, which kind of goes against the whole SIM pricing model, if you think about it, because EPD or events per day based pricing, so, very popular with Splunk and many other products out there today, sort of penalize you for using more data. And so you have to pay a lot of money in order to pull in all of the data. So it kind of runs counter almost to the licensing. And so, again, that's kind of an industry problem. But our focus right here is dynamic threat detection. Okay, and that is really what we're focused on. So we're going to tell you a little bit more about how we do that and how we approach that. This slide right here is called the race to zero. And the idea here is that we want to get to zero in every one of these sectors. There's 4 quadrants, and the quadrants talk about 4 business problems that we have. Whether you're in cyber or IT or on the business side, these are all things that you should be concerned about. The first is the cost of false positives. Okay, so if you're doing this in-house today, meaning you're doing your own threat monitoring or you're relying on a service provider, you know what it's like to actually, spend time chasing down something that turns out to be not real, the proverbial wild goose chase. And, that's costly, right? Because if you're going to triage every single alert, you've got to throw a lot of manpower at this, especially in 3rd and 4th generation solutions. The cost of false positives, whether on the provider side or on if you're doing it in-house, is pretty high. So as you get into like 5th and 6th generation solutions or platforms, which is kind of what the slide is about, you're going to find a reduction in cost of false positives. And then let's move on to the next quadrant, which is the percentage of threats not found. Now, there's no absolute understanding that we have of all of the threats, right? This is an estimation as best as we can tell from some of the data that we've gathered, but nobody can catch all the threats. And we all know about the sort of cat and mouse game going on, right? You get better detection technology, and you get all this AI and ML that's been, everybody's talking about. But guess what? The bad guys are also using AI and ML too. So it's cat and mouse. But percentage of threats not found is a key, I think, decision factor in how you approach this problem. And then really, what is the cost of missed alerts? And the reason why there's no actual dollar amount associated here, because it varies by industry. So in state government and other similar types of organizations, there might be a cost per record, or depending on what the data breach laws are in terms of how it impacts you. And then ultimately, time to find. You might remember the good old days when an attacker would just get inside and then sit there for months and months, maybe even a year. And that was not uncommon for nation-state actors, particularly Chinese and North Koreans, just sit there and watch. And, they'd at some point decide, okay, we're going to go, like in the case of Sony, we don't like their, what's going on, and we're going to go and release a bunch of movies, which is what they did, the North Koreans did. But they'd been in their systems for 9 months to a year before that ever happened. Well, now we have the window of time, particularly in a ransomware attack, down to on average 2 weeks or less, between the time of exploitation into the network and actually encryption of the system. So a 2-week window is not a lot of time, and in some cases it even happens quicker than that. Other times it's a little bit longer. Okay, so, all right, so I won't, this is like a worst day kind of scenario, right? In the cybersecurity world, we think no news is good news. Well, that's not always the case because, we don't always know what's going on under the surface. So, but we cannot assume everything is good just because we're not aware of it. There's always things going on in our environment. So, but we also know that companies are continuing to get compromised today and they don't know it. They don't have awareness about it. This is actually a fellow CEO of a small to medium-sized business. He runs a maquiladora operation right next to the border of Mexico. He has about 250 employees, and they're not like a huge company. But they had 2 terabytes of their data backed up in a cloud. They had it backed up in a different data center in a different country in Mexico, and they had an offline copy, what they thought was an offline copy, and all of those locations were all encrypted by the attacker. The attacker found every one of those data stores and encrypted them. And I don't know exactly technologically how they segmented it and what kind of like the access rules were, but I do know that they found everything that they thought they were safe, doing. So, and this was actually a quote from him. I aged a year and 1 week, and I thought we were prepared, but they had no choice to pay the ransom. As it turns out, the attackers had been surveying him for some time. They had actually cracked into like a Dropbox account and had accessed some files. They knew exactly where they were going and what they were doing. They found out that he had cyber insurance. They found out how much it was for. I mean, there's nothing better to an attacker, especially, a ransomware attacker, if they know how much you're insured for. So it was really not fun. And we wrote this up as a case study, and there's a lot more data around this. But, I won't really go into details. I think the other folks before me have done a pretty good job of laying out, what the costs are that are going on. But certainly the biggest challenge, of course, is that they got you, right? If your systems are encrypted, you're going to do anything to get that data back. And it doesn't matter what the law says or what people in government, tell you to do. And if you're a government entity, what do, right? You have more of your hands tied than a private business, right, who is able to kind of go off and kind of do their own thing. So that's going to be a quandary, that's a big challenge. So why now? Why is all this stuff happening right now? There are a number of reasons. In the early days, ransomware is not entirely new. The very first ransomware in exchange for computer access was developed by Joseph Popp in 1989, called the AIDS Trojan. And what he was doing is he was soliciting donations of about $100 to this cause that he believed in, and that's basically why he wrote this virus. It wasn't really smart. Joseph Popp was not a smart guy because he actually stored the encryption keys on a partition of the hard drive that he compromised. So if you poked around, far enough, you could actually find the file that had the encryption key in it. But he started this whole thing. The next big thing was 2013 propagation of CryptoLocker. Now that was a much more serious type of attack. And as we know, ransomware isn't just about encryption. Sometimes it's about access or about releasing information that they have gotten out of your system that they've exfiltrated. So there's really kind of like 3 different scenarios: encryption, access, and then exfilled data or confidential data release. But it's also, this CryptoLocker is actually pretty important because Bitcoin was used for the very first time. Why? Not very traceable, for one. And he ultimately procured about $27 million from infected users. Now, this is what happens in the world. As soon as somebody's really successful, $27 million bucks, that's a lot of money. That puts Joseph Popp to shame here. but it became widely copied. And this is, again, part of the problem is, if you remember when the NSA and the CIA tools were stolen through a leak from our government, that stuff had been under development for years and years, professionally developed, and then we let all these tools out that only enhanced the hacker community from propagating more attacks. And so what's happened is over time, every successful attack has been built upon, have been modified and improved. And so the technical sophistication of the attacker is pretty low today compared to what it used to be. It used to be you really had to write code and understand all of this stuff in order to launch an attack. Now you can just go and rent some bots and they'll do your dirty work for you. There's a whole ecosystem about this. So there's multiple forces coming together right now in the ransomware proliferation world. Bitcoin adoption, number one. Ransomware as a service model, okay, because that's truly what it's become. It's become a platform. And then rapid shift to remote work. And a lot of companies are staying in a hybrid or even a remote workforce. So this isn't just like a one-time thing. And then social engineering sophistication, the hacking or the phishing, spear phishing, and all kinds of variations of that become very, very sophisticated. And I'm not talking about the obvious misspelled, phish attempts to click on a link. I'm talking about well-designed, English-speaking people that know how to design a good phishing attack. So the criminal ecosystem, this is actually the Revil guy, one of the lead guys from Revil. Those are his cars. He's somewhere over in the eastern, I think he's in Ukraine or Russia or something like that. And he's got a bunch of nice cars. And Revil has sort of been in the news a lot lately. There was a report today that actually says that they've been shut down again, but they'll pop back up as something else. But ransomware is very scalable. They can make massive profits. And remember, in a lot of these Eastern Bloc countries, they have a lot of focus on math and science, and they're really good at writing code, and so but the jobs are relatively low paying comparatively, and so they feel very justified in what they're doing. Morally they think it's totally fine, and if not not completely justified to do. And then it's not all for profit. There's actually a lot of state-sponsored types of attacks going on. So what you might mask itself as, oh, here's somebody doing this for profit, actually might be state-sponsored. There might actually be, one of our adversaries behind it, and often is being masked. So the ransomware as a service model has become very, very popular. It is the #1 form of cybercrime today. So all the people that were doing credit cards and all of that, that's still going on, but a lot of those folks have shifted over. This is an example of really ransomware as a platform. This is the TrickBot platform. And you can see that there are many variations of what you can do with TrickBot. The Ryuk ransomware is probably, Maze and Ryuk are very similar in terms of how they execute, but Ryuk specifically is the dropper that's launched as a result of this particular platform, if that's what you want it to do. So really, as a if let's say I was a disgruntled employee and I wanted to go and screw my employer or something like that, I could go rent one of these things and essentially pay for this attack to be propagated. And well, what do I want to do? Do I want to commit bank fraud? Do I want to do data theft? Do I want to do crypto mining? Oh, ransomware. Pick one, right? Or maybe a couple. And then you pay the money, and then it goes on, and you go forward. But that's just an example of the sophistication of what's going on in the ransomware type of service, which is really what this is. And there's a whole ecosystem out there: people writing the code, people running the platform, people hosting it, people that are collecting the money. Everybody gets a cut, and that is truly become a very sophisticated criminal enterprise. So detecting ransomware, one of the reasons it's so hard to do is because when somebody, when the ransomware executes, it actually emulates like a regular user, right? So they go in, they open files, they do like normal activity. And you might think, well, if I could just put some sort of rate monitoring thing in there, so if they open and close files really fast, or they go do directory traversals, this or that. But they're smarter than that. They know how to avoid detection. They basically want to emulate what a normal user does as much as possible. So they will look to do things to help avoid behavioral detection methods. And so that's one of the reasons why it's very hard. If in the end the encryption is starting to happen, well, that's the end phase. It's kind of too late. So there's a good 2-week, maybe 3-week window between the time you're surveyed and they do manage some sort of client attack and the time things start encrypting, where you can detect and stop these things. But again, it's very hard. And I would not, even though this is like an area that we really focus on and we're experts in, I would not tell you that we can catch or detect all of this, because it's changing all the time. We can detect a lot of behaviors and indicators, but we can't see it all. And one of the reasons why is because the variations are coming out continually and constantly for this. Okay, so let's move on. So we've talked a little bit about ransomware. Now I'd like to talk about kind of a different challenge that we face in data security. Thanks, Joe. See you later. And that problem is the data problem. Okay, and I mentioned this a little bit earlier about the attackers essentially hiding in the data, and that's a huge problem. So security has become a big data problem in my view, and that's just because not just because we have a lot of data, but we have to really figure out what data is meaningful and which isn't. And you don't know at any particular point the full security context of anything that you're receiving and you're analyzing. So you got to be able to have data for post-processing, you got to have data for real-time analysis, you've got to have maybe data warehouse capability to go back and look for things. Like when Microsoft Hafnium came out, or maybe the Kaseya supply chain attack. I mean, everybody was kind of freaked out. Am I vulnerable? Okay, all right, let's go back. Let's go back through the data. Let's look through the last 6 months and see if there's anything in there that we need to be worried about. So we need historical ability, we need real-time ability, we need post-processing ability. There's a lot of pieces to this puzzle. So our approach is security on demand. What we've done is we've developed a big data analytics engine called AQ. And I'll tell you a little bit more about some of the science behind it here in a little bit. But this engine continually analyzes big data and looks at the different kinds of threats that happen. I kind of covered all this, so I'll pick past this. I talked a lot about volume and velocity, but also resource costs. It's not just the licensing, but also takes a lot of CPU memory storage to handle all the data. And then the last piece here, number 4, is really the detection of unknown threats. That's the other big challenge, and that speaks to the dynamic threat problem. But again, the new reality is that the bad guys are taking unfair advantage of us. A lot of this is due to change. As our environments change, as we go through digital transformations, we replace things, we go to the cloud, right? All this chaos is going on in our environment. Things are changing, and it's very difficult to detect, well, what's normal and what's expected versus what's unusual. So the change is a big challenge when we talk about the data. So this gentleman right here, his name is Zadislaw Pawlak. Zadislaw is actually one of the founders of modern artificial intelligence and one of the pioneers in the computer industry. He's from Poland, and in 1982 he developed a branch of mathematics called rough set math. And it's actually an interesting Wikipedia research thing. Take you 5 minutes to read through it before it gets too far into the math side of things. But what he did is he developed this foundational basis for discovering patterns hidden in the data. Okay, and this has become, we use this in order to find the hidden patterns that we use in our AQ analytics engine to find things. But it has a lot of machine learning applications as well. It can be used for feature selection, data reduction, decision rules, pattern extraction, all kinds of things. has a lot of applications. And this is a math formula you're going to be expected to learn. Okay, I'm going to quiz you on at the end. But this particular approach has a lot of applications in cybersecurity. And so what we did, Security on Demand, we bought a company based in Warsaw, Poland 4 years ago. It was a database company that had not made it as a database company. It was truly a data analytics technology. And then we kind of like taught all of these machine learning experts and data scientists that all of them were PhDs, and we taught them cybersecurity. And that's basically what we did, is we modified this engine to help us do 3 things. The first thing is it helped us figure out how to really speed query performance to the tune of about 1,000 times the normal columnar or relational database. So we could get at the data very quickly. The other thing is that the storage size, what we did was this approach is that we build a metadata layer on top of the data lake that's only about 1% or maybe 2 or 3% the original data set size. So we don't have to go back to the raw data in order to do queries. And then the third thing it does is it gave us the ability to find anomalies in the data through some mathematical functions where we could basically analyze something that was expected that didn't occur and say, hey, that's an anomaly. Let's go analyze that a little bit further. So this is essentially how we use it. This device telemetry, that can come through logs, it can be packets, it can be flow data. Primarily we use logs, but we're not limited to that. And then from there we create this layer, this metadata layer called the MDAL. That stands for multi-dimensional access layer. And if you think a little bit about like the game of Jeopardy, where you have to come up with the question, and because the answer is already presented, that's kind of what this MDAL is like for us. We just have to ask all the questions because all of the answers are in this mathematical model. So we have to apply ourselves as domain experts, essentially, to ask it lots of questions. And we do. We ask millions and millions of questions every hour of the data in order to populate our analytics. You know, have we seen this before? Has this occurred on this date and this time before? Have we seen this combination before? And so that's kind of how we interpret that, and then ultimately it feeds our security operations. This is just an example of some recent campaigns that we've analyzed. The Kaseya supply chain attack, over 1,200 domains. That would normally be about a 9-day query, and this is going back through petabytes of data. This is like 6 months of data in our data set across hundreds and hundreds of customers. And that would normally have taken about 9 days. That took us about 8 minutes to go find that. So you can kind of see, you know, I won't read the rest of the slide, but you can kind of see that the value of being able to quickly find indicators. These, again, are the known things that we know to look for in the data. Okay, so this is just one example or one use case of how speed really is important, of speed of sifting through the data. If the next supply chain attack comes out, and you know we've been through a few of these now, Kaseya and SolarWinds and so forth, you're going to want to know very quickly whether or not you have any risk, and you're going to want to get those answers very quickly. So we're focusing on 5 key problem sets: the log volume problem, resource requirements, the ability to analyze all of the data and not just a reduced set of data, and then detection of unknown threats, and then optimizing the data for doing machine learning. So that's kind of a little bit about kind of the technological foundation of what we do. So let's talk a little bit about, going back to the client side, customer side, what are the problem sets? We talked about too much data. We talked a little bit about spending, but costs are still a factor. A lot of organizations that might use something that's event-based or volume-based, they can only cover a subset of their environment because that's all they can afford. Their budget allows them, and so they're leaving a whole bunch of their systems perhaps unmonitored, or maybe using an open source solution like Elk or something to cover that. So cost is a big factor. And then unknown threat detection, we talked about that. That was a little bit around dynamic. And then machine learning optimization. I'm saving the machine learning part for a little bit later because everybody everybody claims they have machine learning, right? So I want to dive into that a little bit more. So for us, what our analysis layers are static rules, pattern matching, single dimensional, multi-dimensional, and you can see that progressively we find more threats as we layer on. Much of the industry, again, has been focused on false positive reduction, but we're not talking a whole lot about false negative reduction. Okay, so false negatives essentially are the threats that get through, things that you don't see because you don't know how to look for them. Okay, and that to me is the biggest, one of the biggest challenges. That's what keeps you all up at night, right? It certainly does me. So this is kind of how the sausage is made from our side of things, how the events are distilled. So the raw log data, we're processing about 150 billion events per day. So this is, numbers are a little bit changed since this was put together. But we're out of this 75 billion raw events, we're creating about 6 million events. This is typically like SIM type correlation. Those are basic correlations. And then from that, you can kind of see that we go through this other layer of analysis called Threat Watch. That's the name of our product, but it's also a type of alert that we generate as we run it through a risk scoring system that we've developed and into alerts where we investigate it. And ultimately, it's around 300 to 400 notifications or phone calls, every week is what we do. This is about a weekly number. And then this is really kind of a larger architecture. I won't spend a lot of time on this. If you're interested in the slides, let me know. We'll send them to you. But the data inputs come from the public cloud, the client premises. They kind of go through the system here. And then we have a couple of different types of machine learning detection mechanisms that we find. And ultimately, once it gets to the SOC, we have the ability to reach out from the SOC and through our response and remediation service, which is an optional add-on, we can actually isolate a process or shut down a system or quarantine it. So, it isn't enough to say that detection in and of itself, which has been around a long time, is really the way forward. We think that this is quickly evolving into don't just tell me about it, I want you to do something about it. So we've seen a dramatic shift in the last year or so where clients are telling us, yes, I want you to, if you see something bad, I want you to quarantine it or take care of it. And there are some automated machine-driven approaches, but I feel it's best to do it with a human in the loop because it's really easy to quarantine somebody who is important. And when that happens, you have a layer 8 problem in your environment, which means you've got somebody who's now going to be on the opposite side of the table complaining about how secure the systems are by quarantining them. All right, so let's talk a little bit about AI and machine learning. So, how many of you have heard from your vendor or a product company that they've got AI and machine learning in their product or solution, right? Anybody not heard that recently? There's not even a commercial that comes on TV that says they don't have AI in their product somewhere, right? We are seeing a big revolution, but we're still in the very infancy of AI. And machine learning is a subset of AI. There's a lot of different types of it, and we're not going to go into that here. But there's a lot of problems with AI, and particularly machine learning, which is what we're going to talk about here in this context. We have formatting of the data, also known as data labeling. And this is a huge problem because a lot of that data wasn't structured so that they can be used by machine learning types of models. So a restructuring of the data is often needed. Adaptability of the models. We have this idea of training of the data, which can take weeks and weeks of time. In fact, for medical, if you're trying to determine if somebody has cancer on an X-ray or a MRI or something, these medical forms of AI, it can take weeks and even months to actually analyze the data. So there's a lot of adaptability and training and retraining of the models that are a big challenge here. And then, as I mentioned here, the amount of time it takes, particularly in cybersecurity, because once you train a model to find a threat, you've got to retrain it because the data changes. So this constant rebaselining of the model is got to be established, and it's got to be done very quickly. So those are some really big challenges when using machine learning in cybersecurity. but it can improve our ability to respond much faster to threats. And so there's obviously, a big advantage to being able to use it if you can figure out how to use it effectively. But of course, as I mentioned earlier, the bad guys are also using it. And I think there was an earlier example in one of the other talks earlier today about the Tom Cruise example where they spoofed the voice and the image of Tom Cruise. Well, that actually happened to a CEO, and he gave a voice command for a cash transfer of about $243,000. And so it's not just limited really to these kinds of situations. Okay, so all right, so finding patterns in the data, finding hidden patterns. So the idea here, there's a big distinction in machine learning between what's called supervised and unsupervised learning. So supervised are all things that you program that you know ahead of time and say this is a threat. Okay, and it's kind of similar to the problem we were talking about earlier, which is you've got to have like signatures and IOCs and rules in order to identify threats. You have to, in other words, recognize in the machine learning world, you have to train the model for itself to recognize a threat, and you do that by telling it ahead of time how to recognize it. Okay, and that's called supervised because it's all about things we know. Now, the other kind of machine learning is what's called unsupervised. Okay, these are things we don't know. We don't know how to tell it to find something. Okay, and that can be obviously more powerful, but it comes with some nuances, let's say. We use a type of unsupervised machine learning in our product. We have actually 3 different machine learning applications. 1 supervised and 2 unsupervised. And if you think about like SIM, and I'm not picking on SIM because SIMs are compatible with our solution, but it's not necessarily required. If you kind of go through the maze, there's a finite set of paths. We know every turn. There's a beginning and end, and there's a set way to get through the maze to navigate it. That's similar to kind of like how we define rules in a solution, right? We know ahead of time what is we create alerts based on what we know is a threat. But what we aren't able to do is we're not able to analyze the infinite permutations of what could be a threat and to analyze them quickly in order to understand if there's something in the data that we've never seen before that we're seeing a change occur. We want to be able to identify that and identify that very quickly. So here's kind of an analogy, post office analogy. So let's say you're lost, you're in a dream, and you're lost in this fog, and you're in a post office. Maybe that is a nightmare, and there's a gazillion mailboxes in there, and you have to find a threat that's in one of those mailboxes. Okay, and you got to go through gazillions of mailboxes, 1.99 to the 46th power. That's how many mailboxes there are, and you have to open every single mailbox to find the threat. Our approach is we know ahead of time what's in the mailbox, so we know what mailbox to go look at. That's essentially what we're doing mathematically on the back end. If you'd like to see the computation, this is actually permutations of 11 of the 63 fields in our database and what the permutations are of 11 of them. If you kind of add them all together, it's 1.99 to the 46 if you add up all the zeros. So we're not, again, going to deep dive into the techie part of it. I just kind of wanted to give you an appreciation for how much analytically is going on behind the scenes as we analyze all the potential paths that can come together. So this is probably a good way to really wrap your head around what we're doing. This is in the format of an artificial neural network. You have the input node, learning node, and you have the output. And so on the input node, we have 11 of the 63 features in our data, things like source IP, destination, port, things like that. And what we're doing is we're doing something called feature selection. We are selecting the most relevant features out of this 63. We only show 11 of them, and we're analyzing all the permutations of that to find things that we've never seen before in the data. And so when you put all this stuff together, we've got 6 things that we put together where we've said we've never seen this source IP, this destination IP, this protocol, in this case it's RDP, going inside of our network, outside to China, as an admin. Okay, and so that's a little bit more of a real-world scenario, and this is the kind of stuff that we identify continually and constantly. Now, I would like to tell you that this is like a magic bullet or silver bullet, and it is wonderful. We thought it was when we first invented this, but what we found is that when we started getting data out of the system, we found every data anomaly in the entire network. So if you stood up a new SAP system or a new SharePoint server or whatever, we found it. Well, but it wasn't a security problem, it was normal. So we still had to go through the data and put it back into more of a security context and say, all right, now I can capture all the data anomalies, but tell me, all right, which one of these are relevant from a security perspective versus just a data perspective, okay? But you can see, this is, again, just an example how powerful this can be if used in the right way. And this is what we've been working on for 2 years. We've been working on this unsupervised model to really perfect it. And we are finding amazing results of it. I mean, we are in environments where they have lots of technology, and they've got dark trace, and they've got a SIM, and all of that, and we plug it in, and in 30 days, we've baselined everything, and we can find things that they didn't know about. Not all of them security issues, but things that act like security issues, and we can identify that. Okay, so if you're on the hunt looking for, as you think about going and talking to vendors, a few questions you can ask. What kind of model is your vendor using, a static or dynamic? How many models? How often does the model need to be retrained? See, I'm turning you all into machine learning experts by just arming you with a few questions. It's going to make you look really smart. How much data do they use to train? Is it all the data, or is it just a subset? How often is the data refreshed? And how do you deal with unknown conditions that were not part of the original training data? So again, even if you don't know half of what this means, it's totally okay. If you ask these questions, I guarantee you your average vendor who tells you they have AI in their product is going to have no clue what you're talking about. and this isn't really, the focus here is not how to stump your vendor, but just to try to be a little more discriminating about, okay, AI, what does that mean? Tell me what kind of machine learning, what does it really do in the product? How does it find stuff? All right, so I'm just going to skip past this. I think we've already talked about ransomware quite a bit, but these are kind of like 5 stages of ransomware, and the idea here is in these scenarios is what kind of things should you be monitoring in your environment to detect things in the early stages of a ransomware attack. And there's 5 things that you should look at. First is initial access. This is sort of like best practices. So, obviously you're going to be logging most of this, if not all of it anyway, but you should really be paying attention to things going on the remote access side. We talked about using MFA, we talked about other kinds of things, but are we looking at, for example, application configuration changes, right? That might be important. And what about credential theft? The problem with credential theft is if somebody's logging in with legitimate credentials, you don't know that their credentials have been compromised. So you've got to be able to behaviorally detect, well, what is that user now doing? Are they now a member of the admin group? Well, they were part of the admin group before. That's a change, right? So we see things like privilege escalations and account changes. Lateral movement, easy to say, really hard to do. There's a lot of noise internally in the network, and lateral movement is actually really hard to detect. But you do want to look at first-time behavior. First time we've seen this. First time this user has done this. First time this machine has ever done this kind of function. And then, persistence. What kinds of perhaps beacon traffic? This speaks a lot to bots, right? And they're beaconing out to command and control kinds of places. But anything encrypted coming out of your network from the inside to the outside, to me, would be a red flag. And then ultimately, encryption activity. Often before ransomware will execute, they'll do a test encryption. And it uses like the built-in encryption engine, often if it's Microsoft, because about 80% of it is Microsoft-based. But isn't that nice that like these operating systems gave the hackers all the tools they need to wreak all the havoc? I mean, that was really kind of them. I appreciate that. But again, they're using legitimate system function calls to do things that make it really hard for us to detect it. Okay, so that's pretty much all about us. This is just, fluff information you don't really need to know, but copy of our buildings. And our R&D team, we have 7 patents on our technology. We're a little different than the typical managed security company because we actually have IP and, papers and all kinds of patents and things that we do. We've recently awarded a EU grant for a couple $1 million. But anyway, if anyone wants to, visit our office in Europe, you're welcome. And then one final slide. I was asked by Kim, our vice president of sales, who's here, to please. She says, Peter, don't let everybody leave without at least talking about the slide. One slide about pricing. Our pricing model is device-based, not volume-based, so you can send as much data as you want. There's no restrictions or limitation. So that makes it really easy. It's very predictable. Also, we've worked a lot. About 38% of our business is actually with state and local governments. We do a lot of, we're doing work with IP Pathways, but in other states, AT&T is probably another partner of ours. We do a lot of stuff in state of Mississippi, state of California, Texas, Florida, Georgia, a few other states as well. So we really understand state government, and we actually have a lot of threat intel that we pool for state government agencies. So you'll find that we can speak your language. But we've also built consortium pricing so that state agencies, counties can all join together and get discounts on pricing, kind of as they band together. And that we know is very attractive, and we've done that in the state of California for all the judicial courts and a few other organizations as well. So please contact Kim if you need more information. Contact your IP Pathways account manager if you'd like to learn more. And, thank you. Any questions? Yes?
Yeah, Peter, just a question. Do you know if you guys are ingesting any of the Einstein or the MSISAC data?
Yeah, we are. Yeah. I mean, FSISAC, Einstein, we've looked at that. It's not, there's some data things that we aren't doing with Einstein for good reason. That's probably a separate discussion. But yeah, the FSISACs and some of the other ISACs, we are ingesting that data. We have a pretty robust threat intel community and a segment inside of our network or our SOC called the Threat Recon Unit. And that is got its own analysts that just do threat research. They aren't part of the normal analyst team, and they're just doing threat research. So we're sending out like threat flash alerts and things like that on fast-moving security issues, as well as publishing papers and doing other kind of like campaign research. So for example, we do see a lot of campaigns levied against state and local governments, where they're just going through and they're methodically looking at a particular application or attack surface to look for a specific vulnerability that's common amongst, state, local government. So we've seen that quite a bit. Yeah. Any other questions? Ready to go, drink some beer. Thanks for, getting through the day. Appreciate it. And I'll be around, and hopefully we'll see you again. We're coming back in a couple of weeks if you'd like to meet or discuss things further. So thank you very much.
Thanks, man. All right. Well, hopefully this was really valuable for everybody that was here, and then the virtual component of this as well. Thanks, everybody. We tried to make this not a long day. And I also want to thank our partners. You guys did a fantastic job. I hope that everybody is a little bit more educated about our security toolkit and just kind of the state of the IT industry right now. Like I said before, you know, it doesn't have to be a dumpster fire, you know, in terms of what 2021 was. So I hope everybody got some useful insight out of this, and we're going to take a bit of a break. So 4 o'clock, if you people staying here, if you want to head up to your rooms, freshen up, drop off your laptops or your bags, and be back down here at 4 o'clock. The bus will leave, and we'll get a couple of really good Iowa craft beers. How's that sound, everybody?